Everybody, this is the edition of Show Me the Code that I've wanted you to join me for quite some time. I've been working so much in the background and just hoping and praying and lighting candles and doing all that fun stuff to get this expert on the line. And I finally got him because I whittled down the questions and got it to be very specific to the topic that we're going to talk about today. But you have to hear what he has to say. I want to introduce to you Sagiv Weiss-Ishai, and I hope I said that right, Sagiv. And I'm going to let him make his introductions for himself because I can't speak for him whatsoever. But in today's episode, we're going to be talking fire service access elevators. So Sagiv, welcome to the edition today of Show Me the Code. Please introduce yourself to everybody that's watching because they need to know your experience and your background and your education and how you can help them to learn about fire service access elevators.
Okay, thank you, Joseph. Thank you for the opportunity. I think many people know me by now, but I'll do a quick introduction. So you said my name correctly. It's Sagiv Weiss-Ishai. Very good. Good job. Awesome. Hyphenated name. I took my wife's name back in December of 1998. She wanted me to take her name, and I said, "Sure, take your name."
Awesome. So that's great.
I was born and raised in Israel as Sagiv Ishai. And met my wife in 1995 in Israel. She did a medical school there and decided to get married. And our kids have the same last name, so it's all good. Like I said, I was born and raised in Israel, and I was actually an officer in the Air Force for many years. Was electrical engineer in Israel, and my last job in the Israeli Air Force, I was the project manager of fire protection systems for the Israeli Air Force. But there is no fire protection field in universities in Israel. So all the fire protection, sprinklers, fire alarm, it's done by mechanical engineers and electrical engineers. But you can't go to university in Israel and study fire protection. Wow. But because my wife, she's from America, and she had to do a residency in the US. So we had to move from Israel to the US. And because I learned about fire protection, it was very interesting. As an electrical engineer, I learned about fire protection. I told my wife, I want you to do your residence in Maryland because I wanted to go and study fire protection engineering in the University of Maryland. It's a 4-year program, but I did it in 2 years because I transferred all my credits from my electrical engineering. So I didn't have to do physics and math and all that. So just took fire protection classes, heat and mass, all that stuff. So I was there in Maryland between 1999 and 2002. In 2002, we moved. My first daughter was born there in Maryland, Baltimore in 2000. She was a millennium kid. September 11 was actually happened while I was in University of Maryland. I remember it. Put my daughter in a daycare, driving to the university, and then when I arrived, the planes hit the Pentagon, and right when I arrived, we lived right between Baltimore and Washington. They told us, everybody get back home, leave the university. And I was rushing back to get my daughter from daycare. That was September 11, when I was there when the planes hit the Pentagon there. So wow. It was crazy. Yeah. So that's why my experience as a fire protection engineering student, University of Maryland, taking my baby home from, he was 1 year old at that time.
Wow.
So in 2002, graduated from University of Maryland. We won the championship. The Terps won the championship that year.
Get that in. There you go.
Yeah, we also had a 75 years hurricane that year that destroyed the College Park. That also happened that year.
No
Yeah,
kidding.
big hurricane. Yeah, it was crazy. So
Wow.
lots of things happening there. I hope it wasn't because of me, but
yeah, no kidding, right?
So we moved to California in 2002, and I started working as a consultant at Hughes Associates at that time, at their office in San Ramon. And with my background in fire protection and specifically electrical system, fire alarm system, I was responsible for the design of a large fire alarm system. I did the design for the Monterey Bay Aquarium system in 2003, other large projects. And yeah, I was working on the large designs and code consulting and project, and I was really into the codes and fire protection. 2007, I became a fire protection engineer in a large city in the Bay Area, and I'm also members in. I'm also serving as a member on a few national committees for elevators and fire alarm, NFPA 72, ASME code. So I'm really into the codes. Also on a few committees in the state of California dealing with elevators and fire code. And one of the things with me, I like to share the knowledge with the industry, with people who are dedicated to what they do, fire alarm guys, consultant, engineers, architects. I think it's a good thing to share the knowledge. Whatever you have, it's not a secret, it's not yours. And I always learn from other people new things. I don't know everything. I'm trying to learn as much as I can, trying to make decisions, but also trying to share the knowledge with a lot of people. One of the things that I've done, it's on my own. I'm not representing anybody, just myself. I have this website that I created. It's called Fire Protection Education, and I provide a few training classes on the things that I think I'm expert on, such as fire alarm systems, elevators, two-way communication system, and general fire protection. That's what I do. That's what I'm passionate about. And that's what I'm doing today, like trying to share the knowledge with you guys.
Yeah,
So
yeah. Well, you've spent all the years of learning, and I think, you know, with the people that I talk to every day, it's always the same questions for them, because I'm not talking with the same people, right? I'm talking with people all across the United States, different jurisdictions, different code interpretations, and the knowledge is always needed, and it's always needed to be reintroduced. So the reason why I created this Show Me the Code vlog is to have a way to bring that information and then have it live in perpetuity, so that people can always go back to it if they need to, you know, go back and reference something because maybe they have a question about something like this. And one of the questions that I've been asked a lot lately, and why this topic is so important, you know, the building codes from 2009 and 2012 started to add in the requirements for fire service access elevators. And now that those permits from that point in time are starting to become reality in these buildings that we're putting up, the questions about fire service access elevators are more prevalent. People are asking about them, and there's a lot of confusion around it because they're just not the knowledge of where to reference this stuff. So you being an expert on elevators, I couldn't think of anybody more that I wanted to ask these questions of and pull that knowledge from your brain and offer it to everybody. But don't give it to everybody, because I want everybody to know Sagiv does have fire protection education available on this topic, and I'll be able to post that information so that you can find out where to do that later on in this conversation. But Sagiv, what are fire service access elevators?
Oh, that's a great thing. So as I spoke in the beginning about the September 11 event, that everybody, I'm pretty sure that everybody who is a little bit older remember exactly what he did that day. So that changed a lot of things and for a lot of people. And one of the things was that definitely how firefighters do their emergency operation in high-rise building, how occupants evacuate this building, and how firefighters doing their emergency operation, such as firefighting, rescue occupants, and things like this. After September 11, there was started at around 2005. There was a big effort, national effort, to come up with a big task group that included many firefighters, consultant, engineers, architects, all stakeholders involved in tall buildings. And the topic was how to make tall buildings safer for the occupants who occupy them, which can be thousands and thousands of people, and how during emergencies have all the tools for firefighters to do their emergency operation, fighting the fires and rescue occupants. And there was a big symposium. It was in the East Coast, in Atlanta, and they developed basically, it was in 2005, and there was like basically two things that were developed after. It was the concept of fire service access elevators and the concept of occupant evacuation elevators. That was the two main things, the outcome that started in 2005. It was based on the September 11 events, but started from 2005. So the thing is with the fire service elevator was the understanding that in high-rise building that can have, 50, 60 stories, 70 stories, 80 stories, they're tall buildings. And as everybody knows, when there is a fire in a building and the fire alarm goes off, the occupants are told to evacuate the building using the stairs. And there is a sign on all this building that says, do not use the elevator, use the stairs. So basically, you cannot evacuate the building using the elevators. The other thing is when firefighters have to respond to the building, the elevator are available with what we call phase 2 in-car operation. So firefighter can potentially recall the elevators, take one or whatever, how many elevators they want, and put a key inside the car, take full control over the elevator, and take the elevator usually to the floors below the fire and do their emergency operation, right? Instead of walking 50-story with all their equipment on the back, on the stairs, they can take an elevator. However, these elevators, the regular elevators, were not protected enough. So there was all kinds of bad things during fires that basically prevented this elevator from being like a useful tool for firefighters. And it drove the firefighter taking the stairs. And that was the main issue. So the main issue with the fire service access elevator was to have an elevator that is safe for firefighters to take during fires. And what it means by safe, it means that the building has an envelope around the elevator and it protects the elevator from bad things, from fire, from heat, from water. Sprinklers are going off during fire events. Water from the sprinkler can get into the elevator. The firefighter are trained. If they see water going into the hoistway during fire, they typically don't take the elevators. So the idea was to prevent all these bad things of getting into the elevators, getting into the hoistway, getting into the cars. And in addition, when the firefighter arrived to the building, they go right to the fire command center on the ground floor. And that's what we talked about, the temperature monitoring system in the lobby and smoke detection. So they can come to the fire command center and have all the information they need to assess the condition of the elevator and say, okay, it looks like this elevator is safe. Now we have more trust on this elevator. We potentially can take this elevator either below the fire floor, or it's protected enough even to take it to the fire floor because it has a protected lobby, protected against water, protected against smoke, and against water. So that was the whole intent. And it started, like you said, in the 2009 IBC.
Right. Now, and if I remember back, I watched a few documentaries on 9/11. I was still coming into my own. I was working at a hospital in Torrance, as a matter of fact, doing installation there, and I was scared because it wasn't a big building, but you never, I didn't know what was going on. And I remember some of those documentaries talked about, they actually had pictures of the firefighters as they were running up the stairs, going against the flow of people who were evacuating. And they had their apparatus on. You're probably carrying 50 pounds of breathing apparatus on you, and then your whole equipment load, 65 pounds. And they're going up 100 floors. I mean, that is immense. Now, the apparatus on the street can't reach that high, so they need to physically go up the stairs. And I mean, it was taking them, from what I understand, 15 to 20 minutes to make that flight up to the 80 floors or wherever they were going to. So these elevators basically were, everybody was consulted about creating a faster way for them to be able to respond to that location, not only for evacuation of the people, but also to respond to the fire. So that makes a lot of sense. And I can see why, we put in shunt trip and we put in recall and all these different operations. So really putting restrictions around these elevators for their use makes a lot of sense. That takes a lot of technology, and obviously there's passenger elevators in these buildings, and there's service elevators that are used in these buildings, and now we have fire service access elevators. So are there differences between occupant evacuation, fire service access elevators, passenger elevators, and service elevators?
Yeah, that's a question that I get a lot, that people don't understand the differences. So the one thing that a lot of people get wrong is they think that the fire service access elevator, it's an elevator dedicated for firefighters during emergency, and it sits there somewhere in the building waiting for firefighters to have an emergency use it. That's completely wrong. A fire service access elevator is just a regular elevator, regular passenger elevator that people are using it every day. They don't even know it's a fire service elevator. It's just a regular passenger elevator. And the amazing thing is that we're talking about an elevator, but there is nothing in the National Elevator Code, Safety Code A17.1/B44, nothing that talks about fire service access elevator. Nothing in the elevator code. So it means that the fire service elevator is just a regular passenger elevator. That's it. Now, you mentioned service elevator, you mentioned freight elevators.
Yeah.
I don't want to take you into all the, I can spend hours talking about the elevator, but the important thing is to understand that in the elevator code, if you look at the elevator code, the National Safety Elevator Code, A17.1, the elevators are divided in general into two groups. They're divided into passenger elevators and freight elevators. There are all kinds of other different elevator, like private residence elevator, like Lula elevator, construction elevator, but these are very rare. The most commons are the passenger elevators and the freight elevators. Now, I don't get into too much, but into the explanation, but freight elevator cannot be fire service elevators, which means that only passenger elevators could serve as fire service elevator. Now, when we talk about service, the word service elevator, a lot of people think that service elevator, it's an elevator, sometimes it's in the back of the house used for furniture and things like that. They think it's a freight elevator. This is a mistake. All service elevators are passenger elevators. And the definition in the elevator code for passenger elevators, it's that the main purpose of this elevator is to carry passenger up and down. Sometimes the passenger take furniture with them and things like this, but it's not freight. Freight elevators, sometimes the doors are going like this, and they're completely different. The freight elevator, the main purpose is to carry freight. Sometimes they have an operator, but it's not for occupants. So freight elevator cannot be used as fire service, and also hydraulic elevator cannot be used. There is all kinds of reasons why. The main one is that the hydraulic elevator requires sprinklers in the machine room. Hydraulic elevator requires shunt trip. And fire service elevator are prohibited from having chant trip. Also, hydraulic elevator can go typically maximum 5, 7. The top one I've seen for hydraulic elevator was 9 floors. But typically we're talking about, when we're talking about fire service elevator, we're talking building over 120 feet. There is no hydraulic elevator that can go that high. So you don't see hydraulic elevators that serve as a fire service access elevators. So that's basically to answer the question in short, fire service elevators are just regular passenger electric traction elevators. They cannot be freight and they cannot be hydraulic.
Wow. And you know, you made some really awesome distinctions there that I didn't even think about, but it's very true that, you know, freight elevators, I've seen those where the doors open up and they're, you know, only a few stops, but service elevators, their main intent is to carry passengers, but those passengers may have larger items with them like furniture, and they get a different naming designation, right?
And service elevator definitely could be fire service access elevator because they are passenger and they're traction.
Ah, got it. Okay. So now, go ahead.
I'm just saying you can potentially have a service elevator that is hydraulic elevator in a shorter building, but it cannot be a fire service elevator.
Right.
But service elevator in a tall building, like let's say 50-story building, you have a service elevator that serves all the floor and in the back of the house. Definitely this one can be a fire service access elevator. The one thing is, another one thing to explain is in the beginning, 2009, when the IBC was developed, there was only one FSAE required. For every building, regardless the occupancy, if it was residential, if it was office, only one FSAE was required, 3,500 pound and serving all the floor and can accommodate a gurney, an ambulance stretcher. That was the requirement in the 2009. However, when the code developed in the 2012 and 15 of the IBC, and then the 2018, and today we're under the 2021, 2 FSAEs are required, and both of them have to be minimum 3,500 pound capacity, and they have to accommodate a stretcher. A lot of people don't understand why the second one was added. The reason was for redundancy, not for firefighting. Firefighters typically don't need 2 full elevators to do the operation. They need 1, but what happens if one is out of service? What happens if one is under inspection? You need to have another one for redundancy, and it has to have the same exact features as the other one. So it cannot be smaller, it cannot be less capacity than the other one. So the minimum 3,500 pounds, and they have to accommodate an ambulance stretcher in size.
I presume they sit in different shafts, right? They're probably in different shafts.
They're not required to sit in different shafts, nothing in the code. So potentially they can be on the same shaft. Okay. A lot of time, the idea was that the section 3007 in the building code requires a large lobby, significantly large lobby for FSAE, 150 square feet with a minimum dimension of 8 feet, which is pretty big. Now, if you do one elevator in one bank of the building and another elevator in another, so you need 2 big lobbies. You need 150 square feet for each. And people said, this is too much. It's taking too much rentable space from the building. So can we have 2 FSAEs in the same lobby? And the answer is yes. So they are both protected. They could be in the same shaft even, but it saves you having 2 big lobbies if you put both FSAEs right next to each other, right? So
yeah. Now the cores of these buildings, you know, I've seen some low-rise, mid-rise, and then high-rise elevators. If they sit in different shafts, because you know they're going to different leveling. Do each one of those independent lobbies require that size lobby, and it has to have all the features of an FSAE, even though they're different elevators per se?
So yeah, so you raised the point here of a banked elevator system. So sure. A lot of the big buildings that have large footprint, they have what we call a bank system. They have the low-rise bank, the mid-rise bank, the high-rise bank, and not all elevators serve all floor. But right. Because the fire service elevator were required to serve all the floor in the building. So you wouldn't see a service elevator broken into 3 banks. It would be just one elevator that serviced the entire building. So potentially, if you had the bank system with a low-rise elevator, mid-rise and high-rise elevator, you would have on the side a service or 2 service elevators that serve all the floors. And this too would be your fire service access elevator. There is a major change in the 2018 and 2021 regarding all floors served, but this is something that could be discussed later. But the intent originally was that the fire service elevator would serve all the floor in the building, including the floor underground. So sometimes the elevator can go below grade, right? So for few code cycle, the fire service elevator would require to serve all the floors below grade. Now there is a change in the IBC, and there is a lot of debate about this, but right now, at least all the floor above needs to be serviced by the fire service access elevator with the 150 square foot lobby. The only floor that is exempt is the ground floor. You don't have to have an enclosed lobby on the ground floor.
Yeah. Now we talk about lobby. So let's talk about lobby infrastructure, right? Because obviously if a firefighter is going into an elevator, he's expecting to, you said go to a floor below. It's assuming that, a floor or 2 below. But I'm assuming they don't ever go to the floor of incident with all the apparatus and then open the doors and like hope that there's not a fire that's going to, blow into the elevator. How would they know where that fire is and if it's made its way into the elevator lobby on that floor of incident? Is there any way that they get some visual indicator or that they're told other than a smoke detector?
So most of the SOPs, the standard operating procedure for firefighters fighting fires in high-rise building, is not to take the elevator to the fire floor. Until there was fire service access elevators, some of the firefighters were trained not even to take any elevator on phase 2. I'm talking about now regular elevator that has phase 2 operation. If the hoistway penetrated the fire floor, firefighter were trained not even to take that elevator. So if you have an elevator, let's say a single shaft in the building, hoistway, 50-story building, and the fire was on floor number 47, and the hoistway penetrated the fire floor, firefighters were trained not to take this elevator, even if it was completely safe. There was no fire in the elevator, and the elevator was remote from the fire, and the fire was on 47, on floor number 47, in a unit or whatever. The firefighter would take the stair. Now, with all the added protection for the FSAEs, so now it's much safer for the firefighter to take the elevator, that elevator, which is super protected by the construction of the shaft, the construction of the lobbies, and the protection from water, heat, and fire. It was much safer for the firefighter to take the elevator to floor number 45, park it below the fire floor, and then it basically most of the time climbing up with 65 pound on their back is safe. Like they can go there in 2 minutes, and now they can just take the stair up to the fire floor and do the operation from below the fire. More than that, the fire service elevator are that safe that potentially if there is a big emergency and you need to rescue occupants and people get injured and things like this, it's safe enough even to take it to the fire floor because it's protected by this big lobby, and the lobby has fire rated doors, and if it's remote enough from the fire, you can even take it to the fire floor. It depends on the incident commander decision, but it has a robust protection around it that protects bad things, and firefighter can operate these elevators during fire emergencies. That's the
so you have the elevator shaft, which is typically 3 hour, right? 3-hour protected?
No, it's 2 hours typically. The code requires more than 4 stories, the shaft to be 2 hours.
Okay, so you have a 2-hour shaft that's protecting just the elevators themselves, and then the elevator lobby
required to be 1 hour.
1 hour, or if you have a 2-hour envelope building, would that be a 2-hour elevator lobby?
Sometimes you know, you have all concrete core and everything is 4 hours, 3 hours, whatever. But the minimum that the code requires in chapter 30, elevator that goes more than 4 stories to be in a 2-hour shaft. That's the requirement for the hoistway. And in section 3007, the lobbies, the minimum requirement for the lobbies is 1 hour with 45-minute doors. So that's the requirement in section 3007. That's the minimum. Now, if you have more than this, if you have all your lobbies and everything is concrete, you have more. But the minimum is 1 hour with the 45-minute door. That's the minimum.
Now, if obviously this is a whole different topic with two-way communications in area of rescue or area of refuge, it's assumed that that rating, the envelope of the building, will transmute itself into that lobby. So you have to provide that level of protection for that lobby for the occupants. So in the event that they had to use that FSAE to evacuate a handicapped individual that's in that lobby that's used that two-way communication system in the lobby, then they would potentially use it to get that individual out of the building?
Correct. So up to the, I think it was the 2012 edition of the IBC, it was required to have in buildings in the stairs what we call areas of refuge. So for people that cannot go down the stairs, people who are disabled or on wheelchair, they cannot go down the stairs, right? And if there was a fire on the floor and everybody is taking the stair and going down, a person on a wheelchair cannot do it. So they would go into the stair enclosure, which was a safe, smoke-proof enclosure with a 2-hour protection with 90-minute doors. And they could go horizontally from the floor and have like a space on every stair, on every level for 2 wheelchairs. Okay, and that used to be the areas of refuge that in the code. Within the development of the codes, there was the requirement for areas of refuge in the stairs. Is basically there is an exception that says that if the building is fully sprinklered and if the building is an RT occupancy, things like this, you don't need to have areas of refuge no longer in the stairs. And the areas of refuge become the elevator lobby because the lobbies are protected. So a person potentially on a wheelchair or person who cannot take the stair can come to the lobby. It is an enclosed lobby. And inside the enclosed lobby, you have this two-way communication that a person can communicate with the firefighters in the fire command center and say, hey, I have a problem and I need evacuation or rescue or whatever. So the elevator lobby, which is protected from heat, from smoke, from water, from all that stuff, become the area of refuge. And this is where you have the two-way communication.
So we're building on the infrastructure now, and now, you know, typically you see a smoke detector and an audio visual in that lobby, you know, obviously giving voice notification to the occupants that are still there that can evacuate. What sort of provisions are built into the code or the standards when it comes to that smoke detector that's right there in that lobby? Is there anything different that smoke detector is supposed to do?
So in a regular elevator, in every lobby, not a high rise, it's required by the elevator code to provide smoke detectors in the lobbies, in the machine rooms, in the control room, to provide what we call phase 1 recall. So it's connected to a fire alarm system. The fire alarm system activates a relay, and the relay connects to the controller, and the controller recalls the elevators. Again, there is a lot into it. I'm not gonna talk about this, but the idea is to take the elevator out of service. So when you have recall, the elevator are going down, doors are open, nobody can take them. Basically, the elevator out of service. When the firefighter arrive to the building, they see the elevator parked, nobody can use them. They can make a decision if they want to use the elevator in phase 2. They can go in the car, put their key in phase 2, and they can take manual full control over the elevator. So typically in a regular building, the smoke detectors in the lobbies, their job is just to generate an alarm. right? If it's a high-rise building with a partial evacuation, it might be only 4 floors, right? The smoke detector on floor 27, it can evacuate floor 27, 28, the floor below. Or in some other building, there are relocation. People do not leave the building. They just go to the stair and re-enter the building. That's another common thing in high-rise building. But that's what the smoke detectors, the typical smoke detectors are doing. They just generate an alarm, provide a signal to the elevator system, and the elevator system recalls the elevator. What happens in fire service elevators, the code requires an extra level of protection, which means that the smoke detector that does the recall is still there, right? Now we have a protected lobby. But the idea is that firefighters that come to the building and now they get an indication from the fire alarm system that was a water flow switch activated in floor number 47, right? So they know there is a fire on floor number 47.
Yeah.
But they want a little bit more information about the lobby, right? So that came from firefighters, and there is a lot of arguing in the industry. Why do we need this? Whatever. But it's in the IBC said that the lobby needs to have a monitoring system for temperature. So again, a lot of discussion about how to do it. There is in NFPA 72, the 2019 edition, section 21.5. There is an annex that specifically gives guidance. How is the, I can say, most simple way to comply? So basically, if you can have in the lobby, right next to the smoke detector that does the recall, you can have a heat detector with 2 temperature stages, 90 degree and 135. This heat detector can provide firefighters with more information from the fire command center. So if the temperature rises in that lobby over 90 degrees, the firefighters and the fire command center can get an indication that there is a temperature rise on a specific lobby. If it's 90 degrees, it's just supervisory. If the temperature continues to rise and it's more than 135, you get an alarm, and the firefighter can see it from the fire command. So that's what we call the temperature FSAE lobbies temperature monitoring, which is specified in NFPA 72.
Wow. Okay. So there's
Extra
graphic
protection
annunciators.
for the lobbies.
Yeah. So there's heat detectors that provide this indicator, and they provide that indicator as an LED down in the fire command center. So the fire department will walk into the fire command center. They'll see the fire alarm panel will say fire alarm, 14th floor, smoke detector, elevator lobby, and then right next to that will be a heat detector, and I'm presuming that there's, a graphic annunciator that sits on the wall that says 14th floor, and it has FSAE temperature panel, and it has those 2 colored LEDs, 90 degrees and then 135 degrees, so that it helps them to know specifically visually that there's something that's happening inside that lobby that they may not want to encounter. From a heat perspective, maybe it's moving its way, the fire's moving its way towards that lobby, and they don't want to use that elevator.
Right. So every fire command center requires to have it's about 17 features that are specified in the IFC section 508 and in the IBC section 911. There is all the features that are required to be in the fire command center. And this feature ours, it needs to have the fire alarm control unit, the smoke control, generator things, the elevator indicators. So the building code and the fire code specify what's the features that are required to be in the fire command center. It's only for high-rise building and only to be used by firefighters during emergencies, right? Wow. Now, when you have a fire service elevator, you have an additional thing, which is, like you said, it's another panel that gives them indication about the temperatures in the lobby. This is required by the IBC section 3007, which sends you to NFPA 72. And NFPA 72, section 3007 say monitoring system for the lobbies in accordance with NFPA 72. A lot of people are saying, what is this? What is this? So now we go to NFPA 72, and NFPA 72, section 21.5 said you need to have building annunciator or fire alarm annunciator that continuously monitor the temperatures in the lobby. A lot of people were debating, can I just put a heat detector? Is that good enough or not? But again, the end of it was that NFPA 72 didn't want to tell you exactly how to do it. So it told you, you have to do it. So potentially if somebody comes to an AHJ and say, I can do it on performance-based and give you like a digital display that does that, the AHJ may approve it, right? There is performance-based and it meets the intent of the code. AHJ may approve it. However, what NFPA 72 committee decided to do, I'm sitting on this committee, to provide guidance, right? Because you don't want people just wander around. So that's why you put it in the annex, and the annex for A.21.5, basically this was like a big thing that all the stakeholders were involved, a lot of fire alarm companies, and they said the most simple thing is to do a heat detector, which is a listed equipment with 2 temperature ranges and like a panel that has 3 LEDs. Green is everything okay, temperature is below 90. Yellow is supervisory condition, and red is greater than 135. So this is just the recommendation of NFPA 72, how to do it the most simple way, but you can do it in other ways on performance-based if approved by AHJ.
Got it. So now we have a smoke control panel, a graphic annunciator that's just a ladder annunciator that says water flow, smoke detectors, heat detectors, tamper switches, and all that, special extinguishing systems. In Los Angeles, you have mechanical test panels that have all of the mechanical systems broken out because they don't want all of the dampers and fans shown on the smoke control panel. It's just a simple switch with well, there are no engaged switches because it's California, and that was eliminated from the building code. But so now you add in this special FSAE graphic annunciator that has those 3 LED ranges, or another performance-based alternative that can get that.
And again, I learned something within my years in the industry. I learned something about AHJs.
What's that?
you go to different jurisdiction and you have all kinds of different AHJs, and they take the code. So the code, you have the model code, the IBC, the IFC, national codes, NFPA 72, and they take this code into the jurisdiction and they look at it and say, I don't like this, I don't like this, or I like this more, and they make their own stuff, right? Like you said, in Los Angeles, they tell you to do that. In other jurisdictions, they tell you to do that. In general, most of them supposed to follow the intent and the big concept, but they take it to all kinds of different directions, and you may see differences between jurisdictions. Some jurisdiction will tell you that you can combine the FSAE with the annunciator as one panel, things like that.
Okay.
So you can see all kinds of things.
So the important thing with that statement is make sure and pick up your phone and contact your local AHJ where the project is and ask the question, right?
Yeah. When you build a new high-rise building over the 120 feet in a specific jurisdiction, you need to know what this jurisdiction wants. And the best thing is to, like you said, pick up the phone and say, hey, tell me, I know these are the national codes, these are the California codes, these are whatever codes, but tell me if you have something special for your jurisdiction. Tell me if you want, where is it? Show me, is it in writing, or you're just telling me what you want? But you want to understand before you do such a big, expensive project, you want to know what they want. So the permit process and the inspection, everything will go smoother. Yeah.
That takes a lot of technology too, because you're putting in additional detectors in the field. So that takes electricians, and that takes the installers, and that takes the programmers, that takes the cost of the actual devices and the copper wiring to make all that work. So yeah, it's probably a good idea to pick up the phone and have that conversation. In what I do with the California Automatic Fire Alarm Association, is we try to synergize the field and the membership with the fire departments by bringing them together and having regular dialogues about how code is interpreted in their jurisdictions. We do these AHJ roundtables, or these expert panels, as we call them, so that these individuals can all kind of get synergy, and maybe a jurisdiction that doesn't have a lot of high rises may work with a jurisdiction that has a lot of high rises, and they say, we never thought about it that way. So, not that they don't talk with one another, but it's just good to bring everybody together to have that and educate.
Yeah, definitely.
So we've talked about the infrastructure, we've talked about building it, we've talked about the technology and how fire alarm works with it. Can you just spit out specifically, and I'm probably going to put next to you all of these different sections for everybody to go to. So, and I don't expect people to just do this education on their own. There are resources, and I'm going to talk about that in a second, for them to be able to get this information to them. But if they were just starting and they were looking at fire service access elevators, it's an engineer, he's young or she's young, they don't really know what they're doing, and the fire inspector says, you've got to have a FSAE, you've got to build all this thing, you got to know what you're doing. Where do they go? So you said the International Building Code 3007.
It starts in the IBC, it starts in section 403. So section 403 in the IBC is the section for high-rise building.
Got it.
And a high-rise building in the IBC is defined as building over 75 feet of the lowest level of fire department access, right? So once you are at 75 feet, you are a high-rise building, and you need to have a fire command center, you need to have a smoke control system if you're in California, and bunch of things that are triggered by the 75 feet. And this is section 403. Now you go to section 403.6, and it tells you, if you have a high-rise building and it's more than 120 feet, today you are required to have 2 fire service elevators in accordance with section 3007. And now 403.6 sent you to 3007, and 3007 has the list of all the building protection around these elevators. That's how it works. And just to tell you about this engineer who are coming to pick up the phone to the fire department and ask the inspector, I'm building a building more than 120 feet, what do I need? Yeah. And the inspector telling him, you need fire service elevator. This engineer is in a big trouble. If he doesn't know that ahead of time, that the building is, they need to have basic knowledge of the code. Yeah. Engineers and consultants and design professional like yourself, you need to have basic understanding of the codes before you come talk to the AJ. You don't want the AJ to educate you. You're supposed to know your job, right? You're supposed to be professional. If you don't, you get training, you learn from more senior people in your industry, but you don't want to come like as a rookie to the AJ and say, you tell me what you need, right? Typically, you want to come to the AJ and say, the code says that I need A, B, C. This is what I read in the codes. Do you have additional things that I didn't see? You have specific thing for your jurisdiction that I didn't know? You have to become prepared. You don't want the AJ to tell you what to do.
Right.
A lot of time you can come to the AJ and you say, the code says I need to do A, B, C, D, but I propose to do something else. I propose to do this. It's even better. Do you approve it? Things like that. That's a good discussion with the AJ as long as you know the basis, what you need to do by the applicable code in the jurisdiction you're doing your project at.
Right. So 3007, 3007 then takes them to, it references in accordance with NFPA 72.
Like one section, only one section in, okay. So there is 2 references in 3007. One of them is to the elevator code and basically said, the regular operation, the phase 1, it's called FEO, firefighter emergency operation, needs to be in accordance with the A17, with the elevator code. So the elevator, just regular elevators designed and installed per the elevator code. Right. There is one more section that talks about the protection around this elevator. Like I said, there is a fire rating protection, there is sprinkler protection, which is prohibited for this elevator. You can't have any sprinklers in the machine room. You can't have sprinkler in the shaft. You cannot have sprinkler anywhere in this elevator. And the idea is that sprinkler triggers shunt trip, and shunt trip may cause trap in firefighters in phase 2, which is the worst condition you can have in a fire service elevator, trap firefighters, right? So you don't want to trap firefighters, you don't want shunt trip, and therefore it's prohibited to have sprinkler in this elevator. That's why you cannot have hydraulic elevator and you cannot have freight elevator, because NFPA 13 requires sprinkler for those elevators, right? So if you go down the list in section 3007, you see one more requirement there. It talks about protection of the monitoring system of the FSAEs in accordance with NFPA 72.
Perfect.
That's the one that sends you back to NFPA 72 and now kicks in section 21.5. And it's just for that portion of the FSAE, which is the protected temperature system in the lobby. Smoke and heat condition in the lobby, continuously monitored. And it's, by the way, it's the same for occupant evacuation elevator. 21.5 and 21.6 have the same protection required by NFPA 72.
Yeah, because we're hitting on FSAE, but it also applies to OEEs as well, the occupant evacuation elevator.
Which is section 3008 in the building code.
So they're back to one another, 3007, 3008, and they're both dealing with the same thing. And I know you can get into that conversation about sprinklers being in the elevator shafts. There's a lot circulated around with that right now. There's some really good nitmams that I hear out there that, you know, we're potentially trying to get these sprinklers out of the shafts because it creates
out of the
a
shaft
big
in
hazard.
California. The California state, effective July 1st, 2021, which is 20 days ago, no sprinklers in the entire state of California required for hydraulic elevators. Hydraulic elevator pits, they're still required in the machine room of hydraulic elevator, but they are taken away from the pit. So the supplement of the CBC 2019 has deleted the two section 8.15.5 from NFPA 13. These two sections that requires the sprinklers and the pit for hydraulic elevator are deleted. This is a huge change in the state of California, which is leading the country on that.
Congratulations. I know you've put in work to make that happen. I know personally the amount of work that's gone into that, and I know it's a heavy load, but you're doing what's right for the industry. So kudos to you for that. So what other relevant information do you have regarding these elevators or installation that we haven't hit on that's of the benefit to the viewers, whether it's a fire inspector, a building code official, building inspector, fire alarm contractor, or elevator contractor? Is there anything that you haven't touched on that could, like a little nugget that they could use?
Yeah, I can just tell you that I get a lot of questions from fire alarm guys and elevator guys, right? So the elevator guys, they know the elevator code, right? The elevator contractor, the elevator consultant, they know the A17.1/B44 National Safety Elevator Code, right? They know everything about elevator, way better than me. They understand elevator. They understand all the cables and all the mechanics and all that stuff. However, in the elevator code, there is a section 2.27 that talks about FAIDs, talking about detectors that are used for recall. And there is a section that talks about chantry. So these sections are sending the guys, the elevator guys, into NFPA codes, into NFPA 13 and NFPA 72. Now the elevator guys, I can say most of them don't really read they leave it to the fire alarm guys.
Right.
Okay, they don't really know in every detail the fire alarm and the sprinkler code. And it goes back that the fire alarm guys, they know fire alarm and supervision and trouble condition and notification and all that, but they don't understand elevator as much as the fire and the elevator code. So there is a big disconnect between the two industries, right? And this is what I'm trying to do with this education. I'm serving on both the committees on NAF, NFPA, and so I'm trying to make these two worlds talk to each other. That's what I'm trying to do, right? So one of the big things is that I get asked a lot by fire alarm guys is you have 4 elevators in the same shaft, in the same bank, and they are operated as a group automatic operation. You tell fire alarm guys group automatic operation, a lot of them look at you, what is it? So now it comes down to the point that the fire alarm guys need to know how many relays they provide to the elevator system, right? Control relays. Mm-hmm. They need to understand that if you have a group automatic operation, the number of relays go by group, right? So if you have a simplex elevator which is mean a single elevator with a single control, you have to give it 3 relays: alternate, designated level, and elevator machine room smoke detector, right? 3. But if you have right next to it another group with 6 elevator, all these 6 elevator will also get 3 relays, right? So these 2 terms of FEO, which is firefighter emergency operation, which the elevator guys really, really know good, phase 1, phase 2. And on the other side is the fire alarm guys that know, you know, fire alarm, relays and all these control relays. They need to understand how to do it, right? Now it comes down to hoistway lights. The FSAE require lights in the hoistway, but the hoistways lights are required to be activated upon FEO. So now the fire alarm guy is saying, hey, what do I do here? First of all, it's hoistway light, how it's related to the fire alarm system. Is it electrical? Is it fire alarm? Do I need to provide a control relay? What the control relay is doing? How do I get the signal from the elevator system? So this is all the stuff that I'm trying to explain, so the 2 industries can work together, meet the intent of the code, and do it right.
So with that being said, you know, you mentioned it earlier. I hear that you provide educational opportunities that go further into these sorts of details on the system. And if that is accurate, that you do have education around FSAEs and OEEs and the interfaces between fire alarm and fire elevators or the fire emergency operation of these systems, how can the person that's watching this get to your curriculum so that they can get educated on that?
Yeah, pretty easy. You see the background, it says FPE. FPE is what I am, fire protection engineer, but it's also a fire protection education. So there is a website, www.fireprotectioneducation.com. You just go into the website and you can see all the trainings that I provide. And class number 3, which is now open, is the class about FSAEs and OEEs plus the OEO. OEO is really neat stuff for the occupant evacuation elevator, how this elevator is operated automatically during fire emergencies upon signals from the fire alarm system. So class number 3 on the www.fireprotectioneducation.com. All the information is there. It's going to be virtual live training, and I allow for people asking questions, and it's a good discussion, but I give you all the code section, all the latest and greatest codes from the 2021 IBC section 3007, 3008, and also all the new changes in NFPA 72, 2022 edition, which was not published yet, but it's coming. It's passed all the Nitman process. and it's going to be published. I can just tell you that there's a major, huge change in section 21.6 for occupant evacuation elevators. So all the engineers and consultants and fire alarm guys, which is crazy complicated interface between the fire alarm system and the elevator system on an occupant evacuation project. I'm going to cover it and make it simple and show you a flow chart, how it works. But I'm deeply involved with this big change in NFPA 72, and I'm going to cover it regarding the operation and the interface between fire alarm systems and elevators.
Ooh, it sounds like you just dropped something that you just.
And the training is going to be broken into 2 4-hour sessions. It's on Thursday and Friday, August 12th and August 13th. 4 hours, 9 a.m. to 1 p.m. Pacific time, California time. So people in the East Coast can take it as well. And if you want to learn about this stuff and you're interested, go on the website and register.
You just dangled the carrot with this new provision for 21.6, the 2022 edition that they're going to need to know about.
It's a major change that a lot of people are now looking into, especially the people with the tall buildings. That it's very interesting. It's going to be changing a lot of concept, and I'm going to cover this.
Wow. So So I will make sure that the link is included in text down at the bottom of this when I publish it. And I'll try to put all the hyperlinks possible to get people to go to that, because I've sat through your two-way communications course, and it was really, really valuable. You went in and you dove deep into the code and into the standard, and you made it really easy to understand. But not only that, I think the ability to be able to ask questions of the expert and have them respond to you in a way that helps you to understand it so that it makes your job easier is what you're doing this for. So, you know, I've wanted to sit down with you for a very long time, Sagiv. I appreciate it, and I know that everybody that's watching it is going to appreciate this, and I hope that they share it with their friends and all of their industry experts, and that we can get people to actually get invested and get involved, whether you're on the East Coast, the West Coast, the Southeast in Florida, you're down in Texas, you're up in Nebraska, or you're over in Seattle, and you just want to understand the nuances of how these systems can interface. Who better than somebody who's on the NFPA committees, who's on the elevator committees, who writes code, who teaches code, to learn from? And that is why I brought him here. Sagiv, you are a gold mine, and you are cherished.
Wow. I'm blushing.
Hey, listen, I'm blushing having you on, man. Thank you so much. Like, I'm not going to be able to take this smile off of my face for about a week, because it's just amazing to have an opportunity to not only speak with a professional like yourself, but to be able to help the industry, because I'm just as passionate about these topics as you are. And I can't speak as eloquently as you when it comes to these codes, and it just comes verbatim to you because you're immersed in it. And so I know that I appreciate it, and I'm sure that everybody else that watches it appreciates it too. So thank you for taking part in this, and I hope everybody that watches goes to www.fireprotectioneducation.com and signs up for that class number 3, because it's coming and it's going to be a great one. So Sagiv, thank you so much again for joining.
Thank you very much, Joseph. Thank you. Appreciate it.
Yeah, absolutely, man. Did that just happen? Like, did that just happen? Seriously? That just happened. I'm really excited about this. I get asked these questions about fire service access elevators and occupant evacuation elevators, and Sagiv has his fire protection education that he does, and a lot of what you got today is just touching on the top level surface of this entire conversation point, and how these technologies work. And you know, you can understand 2 4-hour sessions to go over all the codes and standards, so that you as the public or as a professional in the industry can understand how these systems work. I was able to get an hour of his time so graciously that he offered, and just to dabble into it, to really help everybody to understand how important this subject is. And I hope you were able to get something out of it. And if you don't want to digest the code and have to go read and reference all of this, please send your engineers, your project managers, all of the individuals that are really responsible for bringing the project together where the rubber meets the road, send them to his course, let them learn, and then let them build into your standards how to implement the technology and the hardware to make these systems work properly. This was another Show Me the Code, and I've got some more coming. I don't know how I'm going to top this one, but this was fun. So I hope you enjoyed it. I hope you learned something from it. Thank you for taking part and making my day. And if you can, share this with your connections, share this with your friends, share this with whoever you think it's important. You can share the YouTube link, and just put it out there, because it's so important that people learn how to make these systems operate properly, to keep our first responders safe, to get occupants out of the building, and you know, to make your job a lot easier. So I hope you found it beneficial, and we'll see you next time. Thank you for joining.